vision of Iridium has progressed from an idea to a firm technical reality. Project funding has led to explosive design and manufacturing activity across the entire program. Today, it employs over 4,000 people around the world, and with all major subcontracts now awarded, the number of engineers dedicated to the system soon will reach 6,500. Critical high-level technical design reviews have been conducted on the many satellite subsystems. Thousands of design and manufacturing tasks are underway at companies worldwide to ensure a fully operational wireless communication system in 1998. Great strides have been made in developing the new generation of communications satellites that will form the heart of the Iridium network. Motorola is developing the communications payload, and as Iridium's prime contractor responsible for subcontractor oversight, will integrate all satellite components. Smaller, lighter, and with more capacity than anything in their class, these satellites also must endure the rigors of the orbital environment. So Motorola engineers in Arizona have created new computer models to predict the tremendous variations in temperature that satellites will experience as they orbit the Earth nearly 15 times each day. This data, in turn, has helped the team at Lockheed Missiles and Space Company test the materials and components of the satellite bus, the body of the satellite. Critical mechanical systems, such as those used to deploy the main mission antennas and solar arrays, have been designed, built, and tested in the extreme temperatures predicted by the computer models. Lockheed also has built an automated test facility exclusively for the rapid testing of components in the Iridium satellite bus electronics package. The solar arrays themselves have progressed well beyond the design phase at Lockheed. Engineers now are assembling working models and Iridium-specific components and putting them through their paces. Raytheon is developing the phased array antennas for communications with subscriber equipment on the ground. The first complete engineering model has been built, comprised of more than 100 transmit-receive modules. It is now undergoing rigorous testing before full-scale manufacture of the antenna subsystem by the end of 1994. At Motorola, several tabletop breadboard assemblies, such as this one for the L-band converter of the satellite communications payload, have passed review and are being converted into wafer-thin integrated circuits. When this power converter assembly was tested, its performance exceeded design specifications. Each subsystem provided by Motorola, Raytheon, and the dozens of other subcontractors must fit precisely into the satellite bus. So Lockheed engineers build elaborate structures to check each component against its drawings. Every jig and cradle used in assembling the satellites also must be designed. And engineers rehearse assembly procedures to perfect them well before mass production begins. Our launch vehicle providers, McDonnell Douglas, China Great Wall Industry Corporation, and Khrunichev Enterprise, also have made significant progress during this period. They have been designing the mechanical systems and integration platforms their rockets will use to carry and deploy the satellites into space, and have performed detailed analyses of the loads and stresses involved so they can design for maximum reliability. The ground systems that, coupled with the satellites, will complete the Iridium network also are progressing quickly. Sites in Hawaii and Canada have been selected and are being prepared for the first tracking and telemetry Earth stations, which will house antennas being developed by Scientific Atlanta. Motorola is constructing the engineering control facility in Chandler, Arizona, for launch and early operation activity. It also will be a laboratory for testing system control software for the Iridium Master Control Center to be built in Virginia. A backup control facility will be located in Italy. Motorola already has completed technical review of the Earth Terminal Controller hardware and software. It also is well advanced in designing the sequence of hundreds of digital messages that must be exchanged to initiate and terminate a call. Siemens will provide GSM switching hardware to interconnect the gateways to public telephone networks. And Senti Corporation has designed prototype computer screens that will be used by Iridium operators at gateway sites around the world. The most visible element of the Iridium system will be the Iridium Subscriber Unit, the device that will put global communication ability in the palm of a hand. Handset development began on the workbench in the typical breadboard fashion, leading to application-specific integrated circuits, which permit the miniaturization that's essential for handheld equipment. This early design work has since been packaged and field tested. In this test, a NASA SR-71 research aircraft flying at Mach 3, 75,000 feet above the Earth, is loaded with an Iridium satellite communications payload, piloted on a flight path to precisely simulate the range and movement of an orbiting Iridium satellite. The Iridium Developmental Unit then makes contact with a conventional telephone at the laboratory.
Assuming one shift, there will be 16,486 units in January.
Having demonstrated impressive performance quality, subscriber equipment circuitry has been further miniaturized and is now reduced to these two small circuit boards. This continued evolution will result in palm-sized units produced by Motorola and other qualified manufacturers. Thanks to the commitment, hard work, and support of our industrial and investment partners, personal global communication is becoming a reality. Then the technologies we're developing and the new services we are creating will begin to prove their potential to serve people and open new markets around the world. Welcome to the vision turned reality, Iridium.